This video is about dividing algebraic terms. So we've already done the operations of adding and subtracting and multiplying, and so we're moving on naturally to dividing. And there are a few concepts that I want to reinforce before we get into what to do with pronumerals, and that's shown here in this slide. So I've got this piece here that shouldn't be there. Let's get rid of that. All right, so one important concept that I think is common sense, but I think students often forget once we bring the algebra in, they start getting confused. And that is, if you have a quantity and you divide by the exact same quantity, so 6 divided by 6, that would give you 1. Okay? And it doesn't matter if I write it like this or if I replace my division sign with a bar, it means the same thing. So obviously 6 can fit into itself exactly once. And that students seem to get thrown when I add some negatives in, but if the two quantities are exactly the same, then minus 15 will go into minus 15 exactly once. Okay? If you don't like that, you can always remember that our negatives, when we're dividing, two negatives will make a positive, but really if the quantities are exactly the same, they will cancel out to give 1. And at some point I find students start saying, oh, they cancel to give 0, but it is not 0 that they're giving, it is 1, because 15 or minus 15 will fit inside minus 15 exactly once, or it'll go into it exactly once. The other concept I want to reinforce is the fact that when you have terms connected by multiplication, and we have a term in the numerator that is exactly the same as the term in the denominator, they can cancel out. And we use this word cancel a lot, but really the origins of cancelling is exactly what we discussed above, which is this 5 can go into itself once, and this 5 will go into itself once. So this 5 basically is going into that 5 one time. So this 5 cancels into that 5, leaving me with just this 3, because 3 times 1, anything times by 1 will give me the same number, so I'm left with just the 3. So here, even if I write it like this, this and this expression over here are exactly the same, I can see now that the 5s will actually cancel to give 1, and then that would leave me with just the 3. Now, while cancelling is great, very, very helpful, we can't do it when when the numbers are joined by a plus sign. Okay, so for example here, I can see that 5 plus 3 is 8, and this gives me 8 over 5, which is a little over 1. But if you try and cancel this 5 and this 5 and you get a 1, then it gives you an entirely different result, and a result that makes no sense. So for example, you'd end up with 3 plus 1. So this 3 and this 1 would make 4, and then you have a 1 on the bottom. 4 over 1 is 4. Well, we know that this is definitely not 4. Okay, we can see that 8 on 5 is just a little over 1. So this is not correct. Wrong, this one is correct. And what I really want to reinforce is do not cancel across a plus sign. So let's see how we're going to apply these concepts to pronumerals. So here we have the quantity of m, and we are dividing by the exact same quantity. So they will cancel out, or we can say that m will go exactly into m one time. I can write it with a bar instead of with a division sign, and I'm going to get the exact same result. C will go into C exactly once. So yes, I've cancelled my C's, and then I can start to apply that with some numbers as well. So this R and that R will cancel. This R can go into that R once, so they'll cancel to give 1, but I have a 9, so the answer is 9. Here the D's will cancel, leaving 1, but I don't have to write that because 8 times 1 will just stay as 8, so there's no point writing the 1s. But the 4 here will go into 8 exactly twice, so I'm left with 2. Now we can bring in some minuses. 2 negatives make a positive. My F's I can see will cancel out, so that means I'm left just with 10. Here we've got 2 negatives again, so a negative and a negative will make a positive. I can cancel out my N's, and 8 goes into 24 3 times. Hopefully that all made sense. That's level 1, meaning it's the most basic, I think, kinds of questions. Let's step it up to level 2. So here we've got a 15 and a 3 as my coefficients. I know that 3 goes into 15 5 times. And then here I have an a squared. Now just to remind you, a squared is the same as a times a. So if I cancel an a, change my colour, cancel an a here, then really I'm only going to cancel one of those a's out. And so from my a squared, that power there is going to drop by 1 to a. And that makes sense. So I don't expect you to write it out like this in expanded form, but I think it's quite important to actually understand what's happening and why the a goes from a squared down to a to the power of 1. You don't have to write the 1, but it's just reinforcing for me right now that we've lost this a here. We've cancelled it. So the a squared's become an a because I have to cancel an a from the numerator as well. Over here, I've got an imaginary coefficient of 1. But we know that 12 divided by 1 is 12. So it doesn't matter whether there's a coefficient of 1 there. This will just be the coefficient in the end. And I can cancel a p. I've got a p in the numerator over here and a p in the denominator over here. So when I cancel this p over here in the denominator, then this p cubed, which is p times p times p, well, I'm going to have to lose one of those p's. I'm going to have to cancel it with this p, with the p that I've cancelled here. So all I'm left with is p times p. And p times p is p squared. Now, once again, I'm not suggesting that you have to write this out. I'm just making sure you understand why when I cancel this p here, why this power of 3 will now change to a power of 2. Here, we're getting a bit more fiddly, more negatives, more coefficients. So I've got 2 negatives here. We know that makes a plus, so I don't have to write anything. I know that 18 divided by 2 is 9, so I'm dealing with my coefficients next. And then I have g squared and g squared. Well, when they're exactly the same, they will cancel out, leaving me just with 9. Now let's check your understanding here. I've got j to the power of 5, so that is j times j times j. That's 3 times 4 times, and 5 times. So when I cancel this j, then I would have to cancel 1 here, which means I still have j times j times j times j, which is j to the power of 4. If you're starting to see what's happening, you don't have to write it out. All right, last example. 2 negatives, make a positive. So we've got a positive. Now this k squared, that's k times k. K times k. And I've got k to the power of 4, that's k times k times k times k. So if I took out both of those, then I would need to do the same from the numerator. So my powers this time around would go down by 2. I'm left with just a k squared. All right, time for your test. So here are some questions for you to do, and this is the time where you pause the video, give them a go, write down your answers, and then I'm going to reveal the answers in the next slide. So pause your video now. Okay. So the answers to the questions are here. I want you to check your work. And if you get any wrong, I want you to have a think about what's been explained in the previous slides and see if you can figure out where you've made your mistake. I think we've done enough examples for you to be able to find your error. Usually errors are things to do with signs. Maybe you divided your numbers incorrectly. Maybe you forgot to cancel. So go through your mistakes and make sure you fully understand how to divide algebraic terms.